All right, so this is October, November 2016, question one, right? So the application needs to manage customer records. A second-year student provided the following UML class diagram as part of the solution. Okay, there you go. Identify one design anti-pattern in the above design and explain why you think it is a problem. Okay, so I think this is pretty straightforward. We've identified this to be the God object anti-pattern because the class is burdened with too many responsibilities. It's a customer, it's a list, and it's also a serializer. So definitely it's the God object anti-pattern. It's also a list at the same time. So that's all you are explaining there. Number 1.2. Using a UML class diagram, provide a better design for the solution. So that's a very, given the number of marks, pretty easy thing to do. So what you want to do in this case, as we've always been discussing, is whenever you are trying to draw a UML class diagram, understand what you're looking for. And I'm going to repeat this set of guidelines that you use to identify what classes you need and what relationships you need. And just as a quick summary, we said, number one, identify the entities, right? The entities or the objects. These are normally things that has an attribute, right? Has an attribute. Because all these become classes. For example, if something says, this thing has an ID, that means it's a class because where do you put that ID? So anything that is an attribute becomes a class. For example, a customer is a name, is a phone number, is an email. All these things will hint you that this is a class. So we know that customer is a class or an object, that's an entity. Those become classes. Number two, we said containers. A list of something, a list of, that also usually becomes a class. So if you've got a customer list or whatever list of items, that list needs to become a class. Number three, we said anything that serializes, right? Or writes to a file or creates something from the data that you have, that becomes a class. Number four, we said something that deserializes, something, the reverse serializes. Something that reads from a file or reads or converts from XML to something, that also becomes a class. And something that the GUI also becomes a class. Anything that you use for user input, that's usually very easy to detect. This is just there, but normally that's not a problem. So these are the basic guidelines that you use to identify what becomes a class, and so forth. So in this case, looking at this, we know that we are going to have a class for the list, right? We are going to have a class for the, sorry, this is just get list. That's not a problem. A class that writes to XML and a class for the customer itself. What else has to become a class here? That's all. So we're going to end up with three classes. One, that's a customer. Number two, a list of customers. Number three, write to XML, which is something that's going to serialize to a customer, right? And that's it. Then this is your client, which is your GUI. So that's already a class in this case. That's fine. So another thing that we talked about when building your classes here is inheritance. Usually, whenever you've got types of objects, you end up with inheritance. Like, let's say if you had types of customers, then you would move towards inheritance to accommodate all those different types of customers. But in this example, we don't have types of customers. So there's no inheritance going on here. But if we were looking at maybe contracts or contract customers and prepaid customers, for example, you would possibly have two types of classes or inheriting from a customer class. But in this case, there's none of that. So moving on now, drawing this diagram, we do know that we've got a customer, and this customer is going to be in a customer list. And your list is going to just usually inherit from some form of a container. So you can have a queue list of type customer to make your list. Then you're going to do, so we've got customer list. We're going to do serialization. Serialization, we can have a customer writer, which then creates XML. And that serialization, a serializer is an association relationship with the entity. So it can just be like this, for example. So what I've done here, we do know that whenever you do the serialization pattern, all you're doing is you've got an object that needs to be returned to a file or to be serialized to something. You've got a writer and you've got a reader there. And both we have association relationship with your object. That's the serializer pattern. In this case, we don't have a writer, a reader, we only have a writer. So generally speaking, that's the kind of sketch you're going to end up with, which then in this case covers your customer, covers your customer list, covers your writer, and you've got your client. Now, in this case, your client is going to be responsible for the customer list and the customer writer. So you can have your client this side. Your client is obviously going to have to have an instance of your list because it's going to keep track of your list. So you can put aggregation there. And your client is going to use your customer writer to serialize to XML. I've gone fast, but let's have some questions. But that's generally your sketch. And if there's something that you are missing or if it's confusing, then it means you are missing something that I possibly haven't explained. But I can only know if you ask a question, especially the questions that you think are dumb questions or stupid questions. Those are the good questions that most people don't ask because they think like, maybe it's just me. But I promise you, most of the times, it's those questions that you don't ask thinking maybe it's a dumb question that will actually get you. And those are the questions that usually make a huge difference. But generally, yeah, that's how you move from this diagram to this. The only thing I haven't done is to put the actual customer attributes. So your attributes here, these ones would go under customer. Your functions here would remain under customer. Like all of this stuff here would still be under customer. Your customer list, your get email, whatever, up to here, this remains in customer. This get list becomes part of your list. This to XML becomes part of your writer. Yeah, and that's it. That's your diagram. So that's your sketch for this. Now, looking at this diagram, given that you looked at this and possibly you were stuck, and now looking at this diagram here, what do you think? Do you have a question? Because maybe you are missing something. And the questions are that you need to ask yourself is why couldn't I come up with this? Those are the gray areas we need to address. So looking at the diagram, which part is not really making sense? Which arrows are not really making sense? Or which part are you going, why did you do it that way? Or how did you figure out to do it that way? Then I can explain how I got to where I am. And then in doing that, it also helps you understand why I did what I did.
Yeah, Edmund, there's something I'm confused about here.
Yes.
It's given in the question, but now why is the relation between the customer list and the client? This is an application.
Yes, good. That's a good question. Why is the relationship between your question is here? Why do we have this and then that different relationships like this, right? This.
Yes.
Good. Yeah. So before I answer you, there's also a question on the XML stream writer and QXML simple reader. I don't know if this question is related to this one or that's just a different question. Is that Kolani there? Just clarify so that I can know if it's part of this, or that's a different question? Okay, you are not on mute, but I cannot hear you. Maybe your device. Okay, I've seen videos for creating XML using DOM and StreamReader, but not Simple Reader. Okay, to answer you quickly, there's no, you cannot create XML using a Simple Reader. So I'll come back to you shortly. I just wanted to clarify if it's part of this question or not. So I'll answer you in detail just now. Okay, let's come back to the first question about what's going on here. So it's really important to understand these types of relationships, like when is it aggregation and when is it association, right? And there's a video that you've got already that tries to explain that, but maybe not conclusively. If you go to your video list and look for a video that says, I should have it. Definitely, I remember it was there. Let me see if it's still there. Oh, I didn't put it. Oh, there's a relationships video somewhere. Okay, maybe it's not there. Okay, I'll try and find it. So it was a very short 5-minute video. Oh, it's there, a brief explanation on relationships for UML. It's a 6-minute video. So also just watch that one to understand relationships better. But anyway, so when it comes to relationships, we've got composition, we've got aggregation, and we've got association. It can get more complex than this, but for the purposes of our studies, that's how far we go. Aggregation and composition are more like related, very close. The only difference being that here you are using pointers and deleting them and cleaning up afterwards. That's what makes it composition. So let's now talk about composition, aggregation, and association. These relationships are simply illustrating what's going on in the class, right? So, for example, if I define a class, customer, in this case, class, customer, and in this class, I do whatever I do in here. Put your classes, then here, I put stuff, right? So let's go QString name. These stuff that you put here under private, that's your aggregation or composition. Is that simple? This stuff that your class stores, that's your aggregation and composition. If it's not a pointer and it's not being managed by you, then it's aggregation. If it's a pointer that you are managing, then it's composition. Assuming that you then have a destructor that deletes it afterwards, then it becomes composition. So as it stands right now, we can say customer is an aggregation relationship with QString. So anything that your class keeps as an instance, is a data member, that's aggregation. If it's a pointer that you delete afterwards, then it's composition. That's what makes it aggregation or composition, right? That's all. So if I'm going to draw a diagram for this, then I'm simply going here, customer has an instance of type QString. That's all. Or stores an instance of type QString. That's what's happening. So it becomes a little bit more complicated when you see it in a UML diagram, but that's what it simply means. It simply means customer stores a QString as a data member or whatever, or however way it's doing it. But it does store these instances within the class. That's what you see here. Because customer list has a whole list of customers that it stores or that it keeps, even though it's achieving it via inheritance, but it's the same thing. This queue list can be put under private and customer list. That's another way of doing this class, yeah? Where you go customer list, then inside the class, you put a queue list, but you're storing them. So it becomes aggregation. But because these are pointers and you're going to be deleting them when customer list is deleted, this becomes composition. There. But if you decide to not make them pointers, for whatever reason, I would not recommend it, then it becomes aggregation. So aggregation composition simply means your class has an instance of that class within it. It stores it, an actual instance that it keeps, right? That's what aggregation or composition means. Association means your class doesn't keep an instance, but it uses it somewhere. For example, if customer has a function here that says checkout, and this customer and this function takes an item class I. As it stands now, there's no item that this class stores. But if you look within the class, it does use an item. So in other words, this class customer knows about item, even though it doesn't store an instance of item. That's association. So you can now say customer knows about item. That's association. It doesn't keep an instance of that class, but it knows about it. It's used somewhere within the functions. That's association. So aggregation composition, you are simply saying your class keeps an instance of that other class. Then it becomes aggregation or composition. What differentiates between aggregation and composition is simply that if you are storing a pointer and your class is responsible for deleting that pointer when it's destroyed, then it becomes composition. If it's not a pointer, then it's just aggregation. That's the difference. So coming back to this diagram, and let me know if you're missing something here so that I can further explain. So coming back to this diagram, the question then becomes, how then did this become aggregation, but this association? The reason is, assume that we are making a GUI class, right? A graphical user interface for this thing here. In your client or in your widget, for example, you're going to realize that our class here, let's say we call it client, right? And it's a dialog. So it inherits from public queue dialog or queue widget, whatever you use, right? You're going to realize that within this class, under private, we have to keep an instance of the list so that we can add items to the list. We can do whatever we need to do. So under here, you're going to have a customer list, list, like that, right? There. And you are going to have functions in your dialog to add new customers, to delete customers, whatever you need to do. But all those functions are going to be manipulating this list here, right? Including a function that says maybe create XML, right? Let's say for the function that says create XML. This function might look like this. Doesn't take any parameters, doesn't take anything. But if we go to the implementation of this function, you're going to realize that this function might end up with something like, we can go, in the function implementation for create XML, we can simply call a function of our XML writer. So we can go XML writer or customer writer. Then we go writer dot create XML, and we give this a list, our list, which is this list here, and maybe a path where to write the XML, like that. This is possibly how we can implement this function. So looking at this function, create XML, it's going to need to define an instance of our writer and then use that writer to then generate the XML. But do we have to make it, do we have to store an instance of our writer under private? We actually don't, because we only need it when we use it inside our function. So looking at the class definition, you will never see a writer here defined under private because you just use it when you need it. But your list has to be defined here because you can have a whole bunch of functions like add customer here. That's going to maybe from the GUI, get whatever the user is typed, make a customer, put in this list. You can have another function, delete customers here. All these functions are going to be manipulating this list here. So what this means is we need to have an instance of our list somewhere in our client that we actually store under private. But we don't need an instance under private of our writer because we simply define it when we need to use it inside this function. So we can then say our client knows about writer. It doesn't store it. So the relationship between client and writer is association. But our client actually has an instance of our customer list under private. It stores customers. Therefore, this becomes aggregation or composition, right? In this case, it might become composition because you can then say when your client is closed, delete the list. But usually you go with aggregation because you can have another client using the same list or whatever. And generally speaking, you're going to realize that every time you have a container, your client is always going to have an aggregation relationship with your container all the time, all the time. So you can sort of like, say whenever I've got a container, it's going to be aggregation with my client because we have to keep this container here to keep track of what's in the container within our client. So this is sort of like, we can safely say this is always like this. Always, sort of. Then your readers and your writers, we can also say these are always association because you hardly ever need to keep an instance of a reader or a writer within your client because those are meant to be used whenever you need to use it. And in most cases, if we are going to actually implement our writer and our reader, the write function or the read function might be static. So you can always see that your client is always going to have an aggregation with your container and always association with your readers and your writers, or even your factory, always association. So the only one thing that your client needs to have aggregation with in most cases and in most diagrams is your container. The rest of the classes, usually it's just association for all of them. So if you've gone through many examples, you will see that your client should have association with your factory if we had one, with your readers, with your writers, if we had all of that, that would be association. But with your container or your list of items, your client would have aggregation with that. So that's the general takeaway from these kind of questions. That's generally what it looks like. So if you are confused, make it aggregation if there's a container. Make it association if with everything else. It will be safer that way because it's most likely going to be like that. Okay. The next question was, I've never seen videos for creating XML. I've seen videos for creating XML with DOM and StreamWriter, but not Simple Reader or anything else. Now, addressing that question, when it comes to XML, right? You are going to read XML or you're going to write XML. When it comes to reading XML, you can use DOM, you can use SACS, you can use QXML, StreamReader. When it comes to write XML, you can use DOM, you can use QXML, StreamWriter. Only those two options. So SACS, that's where you then use your Simple Reader as part of the setup. But yeah, those are the options. So you never use SACS to write XML. No, only for reading. But DOM and Stream, you can use those for reading or for writing. And I've said your first prize is doing what you did during the assignments, because usually that's what they go for in the final exam. So you have to find out, we've discussed that already, which one we did during assignments, learn that first, then the rest is a bonus. But most likely, they normally use whatever you used during assignments when it comes to asking questions. So if you were writing with DOM during assignments, you are most likely going to see a question that wants you to write with DOM. Assignment 3, if not 2, question 3, you were reading XML with SACS originally, but it was changed to QXML Simple Reader, which we've already discussed. Unfortunately, you won't find past exam papers with QXML Stream Reader, but we've talked about it. Says that just try to make it a bit larger. Okay, so given the books to XML class definition and partial implementation of the write function below, complete the implementation of the write function so that it produces the XML given below. Use reflective abilities of the classes that were implemented in 2.1. Comments have been included to guide you where the code has been added. Okay. This is one question that you should also be able to do even without the guided comments, because there's only one way you can do it, with or without the comments. And it's also quite a common question that I've seen in different exam papers that I wish and hope that you familiarize yourself with this kind of question where you create XML using reflection. Sometimes it's done with DOM, sometimes it's done with a stream writer. In this case, it was being done with a stream writer. So you are creating XML from classes, from a list, from a container of some sort of a class, and using reflection to then read the data that you need for your XML, right? So if we go to the XML, for instance, here, we need the type of book, right? We need the title for the book. Those are the only two things that you need to generate this XML, which is great because during exams, they don't give you a lot to do. They just give you one thing or two things to test your understanding of the topic. So all you've got to read is the type and the title. That's all you need to create an XML. The XML itself is also not difficult because it's a book that is an attribute. Inside book, you've got a title. That's it, right? So for you to do this question, there are two things you've got to know. Number one, do you know how to write XML? In this case, with a stream writer. So forget reflection. Can you use a stream writer to generate this XML? That's the first question you've got to ask yourself. If not, then you've got to address this. The second question that you've got to answer is, do you know how to use reflection to read all data in a class list? Can you do that? Can you use reflection to read everything within a list of classes? Because this is the knowledge you need to do this question, right? So by looking at the question, if you've done your practice, you realize that this is not the only question that looks like this. And that is important, especially when answering exams, to look at a question and know exactly what that question is really about. It helps you to simplify the question. It helps you to understand what is required in that question. And therefore, you know what the answer is. So if you're going to look for something, you know exactly what you're looking for because you know what the answer is, you know what they expect or what they want. So within this question, You are simply expected to generate XML using values that you are getting from reflection. That's this question. It is not the only one. There's many of them like this that I've seen. So coming back now to the question, now that we know what this question is all about, they have given you a books to XML class, and they say you are implementing the right function. So this is not important because that's this function. What they've done is they've given you the whole class and said, this is the function that we want you to implement, and here's the function. So you are not spending any time looking into this. You don't need anything here because this function is this function. They've just said, here's the class, here's the function. So now implement this function. So you're not really, this is not helping you in any way. It's just there to help you with context, right? Or to help you with confusion if you're not prepared. But it's just there. But here's the function, right? Books to XML, the right function. This function receives a list of books and a file name. The file name is where to write the XML. Like this is the thing that you need. If it's a stream reader, if it's a stream writer, you need this to set up your stream writer. And that has been done for you already there. Q file, writer that, up to this line here. So the setup has been done, right? They've done the whole setup for you to then use your stream writer. So it's been done for you. So you don't have to worry about this. Now, the only thing you've got to worry about now is now that I've got my stream writer and I've got my list of books, how then am I going to go through these books and read everything and use that information to then generate the XML, which is these two things I said you need to know for this question, right? They've already written the document for you. So that's done because that's the first thing you do. So they said the document, done. What is the next thing you do? Now you do the book list element. At this point, you're not worried about reflection because you're always going to have to do the book list element anyway. And you're going to have to close it at the bottom, right? So using a stream writer, how do you make a book list element? And here's a comment to help you with that. Add code to start the book list element. They really made this question easier by telling you where you need to do what. So, and even if they had not put that comment, that is what you would have done anyway, because you have to do the book list first, this tag. So for that, you are simply going writer.write start element. And your element is book list. There, done. Then, because of love that UNISA has for you, they have given you this line. This line can be a question in other papers, but they said, okay, here is how you get the list from your book list instance. So this line says, here's your list. You use the get list function of book list to get the list. You've got your list now, right? Now that you've got your list, what do? Remember, these books are many, right? So you're going to have to loop here. For each book, you have to do this one, you do this one, but remember, you only do the XML once because it's being done in a loop. So what do? Here you loop your books. And for each book, what do? You generate the XML, which is this XML here. So you're only doing it once, which means you're only worried about generating this block of XML. This block. And it's going to be done in a loop. So this block is the same as the one behind it, and so forth and so forth and so forth. So you only focus on how do I generate this XML in this block. It is a book. What you need, book type, and then the title. And that's it. So for each book, thank you. For each book, what do? Now they tell you, for you to generate a book element, what do you need? You need the type, right? Which is this. What type is it? And what else do you need? The title of the book. So you need to get the type of the book and you need to get the title of the book, right? Now, looking at your classes from 2.1, 2.1, I'm not going to show it on the screen. You can go and look at the paper later. 2.1 has given you all the classes. You've got fiction as a class. You've got book. Actually, it's like this. So from 2.1 of this question, you've got these classes. You've got book, then you've got fiction, which inherits from book, and then you've got nonfiction, which also inherits from book. These are the three classes you're given in 2.1. So in other words, you've got book here, and then you've got inheritance, then you've got fiction, and then you've got nonfiction. That's what you've got from 2.1. So looking at the XML that you're given, type is the type of book, which is what? The name of the class. Is it this or is it that? So using reflection, what do you want to do here? You want to get the class name of that book so that you can use that as the attribute here using reflection. So use meta objects to find what type of book it is. That's exactly what they are telling you. Find what type of book it is. Get the name of the class for that book. What else do you want? Use meta objects to find the book title. Again, this is a property within the book. So in other words, you're using meta objects to get the property and its value, right? So in other words, the question then becomes, can you, this here, can you use reflection or meta objects to get, number one, a class name, number two, prop names, and values? Even though for this question, you only need the values, not the property names. That's what you need to do this part. So that's what they're asking you to do. Can you now use reflection to get those two things? Once you've got the class name and the title of the book, can you just generate the XML, which is using your stream writer? Can you then generate this XML? So, which is all easy to do if you know how to use reflection. And we've talked about this countless times. And I've said, if there is code, you should not go to the exam not knowing, it's reflection. So within your, for each statement, right? For each book, book, is it for each book? Oh, yeah, for each book. Well, in this case, it's not a pointer. I'm just gonna stick with it. For each book that you have within your book list there. What are you going to do? Get your meta object. So you're going to go constant q meta object, whatever name you give it, equals book dot. Now, if it's not a pointer, the function is static meta object. But that's not important. Even if you just go with meta object, maybe you can lose a mark or so, but that's fine. So that's your meta object. Then how do you get the class name? QString class name or book type, whatever you want to call it, equals meta dot class name. That's how you get the name of the class, right? Now you want to get the book title. Now, in this case, we only have the title of the book. But remember, when generating XML, we don't assume that we know what the property name or value is. So within your XML, title is the name of the property. This is the value of the property. So you realize that your tag here is made up of prop name and then prop value. That's your XML. That's what it looks like. So the name of the property, the value of the property. If there's many properties, then you only do that once. So this is just one, but they could have been two, they could have been three. So within your book, you've got a property called title. Within fiction, there's another property. Within nonfiction, there's another property. So your XML here is simply your property names and values. So your element is the property name, your value is the property value. That's all what's going on here. So how do you read property names and values? You do another loop. So you go for int I equals 1, I less than meta dot property count I plus plus. There. Then within your for loop, you get your meta property. So you go Q meta property. I'm just going to call this M prop equals meta dot property at index I, like that. Once you get your meta property, now you can get your property name and value. So I can go constant char prop name equals mprop dot name. There. Then your property value, qstring, prop value equals, there are two ways of doing this. I'm going to go with one of the two ways. Again, your mprop dot read your book. Actually, you know what? I'm going to go the other way. Let's just go book dot property. Your property is prop name. This gives you a equivalent dot to string. So now I've got my type of book. I've got my property name and my property value. So this happens in a loop because you can have many properties, right? So what needs to happen is within this loop, that's when you do your property, these ones. But this one should be done outside the loop, right? This should be done outside the loop. So what you are doing is here, outside the loop, that's where you want to do this. And then this inside the loop. But assuming if this was just one property, then it didn't matter where you do that. You could just do everything here. I did something. Geez, what did I do? What did I do? No chance. Did I just? Oh, okay. So what I would then want to do is let's generate the book XML here at the top, right? So I can possibly do this so that I can move this to the bottom a little bit. Edge current page. Okay. Let's remove this. Here, let's get rid of all of that. Okay. So what you want to do is, how do you generate your XML? So here I can go writer dot write start element. And this is my book, right? Which is the book element. Then I want the type and the value. So type fiction. So what you do, you write the attribute. So you can go writer dot write attribute. The name of the attribute is type. The value of the attribute is your class name. So this will do your book type equals fiction. Then once I'm done, then I can go into the loop, which is doing the inside of your XML, which is this part here, title and its value. So I can go now, writer dot write start element. The element name is your name of your property name. So I can go prop name. Then writer dot write, is it characters? I think so, not sure. And that's the value, which is your prop value. Prop value. Then what do? Then you close your tag, right? Your title. So I have to go writer dot write and elements. This one here closes the property or the title. So outside this loop, so this loop ends here. So this loop is going to do everything that's inside your book. When this loop is done, what do? You close your book, right? At the end, you have to close your book and then your book is done. So at the end of the loop, I have to write writer dot write and element. And this closes book. So remember, your stream goes top to bottom. It does this part, then this, then that, then this, then that, then it closes, It keeps going, and when it's done, it closes your book list. So the book list is closed outside the for each loop because you have to close your book list. And I think that possibly was done for you here. Add code to end the book list element outside your for each. So they'd put it for you already, but this is again writer.write end element. That's it. So when you close a tag, you don't specify the name, you simply go write because it's hierarchical, so it knows which one to close. So this is what you would put also there. That's generally what you are doing. So you're using reflection to get your meta property and your class name. You are using XML to write your book tag and its attribute. Then you use reflection to get your property names and values. Then you use your writer to then write the XML using your values that you got from the XML. That's generally what's happening there. So you have to learn the reflection, you have to learn how to use the XML stream writer in this case. But there's nothing new here. It's just a matter of practice. That's how you do reflection and XML together. Okay, I think yeah, there's need to practice obviously and get used to this. So let's keep on practicing. I'm seeing you again tomorrow, same time. And please, let's try and send these questions in advance so that I can prepare, because we can waste 5 minutes or so just looking for questions and also asking for people to ask questions. That also takes a bit of time. So it's better if we just start the lesson and we jump straight into questions instead of probing them out of you for 10 minutes or so. So please, let's try and do that. When this video is ready, I'm going to put it at the bottom in your sheet, which has the list of videos. So I'm just going to edit in that same Google Sheet. All right. Otherwise, yeah, that's it. So let's keep practicing. Tomorrow, I'm going to keep on counting down for you.